This conference will now be recorded.
Hello, Math 211 students. This is section 4.3. And there was one example we didn't do in class because we were trying to get through, I think, 2 sections of notes this day. So we needed to find g prime of x, which is the derivative of g, using both parts of the fundamental theorem of calculus. So we want to show you using part 1 and part 2. When g of x is equal to an integral from 0 to x of 2 plus sine t dt. So I'm going to use the fundamental theorem of calculus part 1 first, which says that if you have an integral where it is set up from 0 or any constant essentially to the variable of the function here, so that's x, and this one doesn't have any weird u substitution, this is directly x, then we can find the derivative by just directly plugging x into the function value. So g prime of x is equal to d dx of this, so 0 to x of 2 plus sine t dt. And we learned that it's a direct substitution here. So g prime of x is 2 plus sine of x. So since this fit the fundamental theorem of calculus 1 perfectly, it is just plug it in and show that that's now the derivative. And remember, this is because we're integrating and taking an integral with respect to the same variable exactly. So essentially, you just get your interior function evaluated at your variable. So FTC2 says that if we want to integrate this, so we have g of x from 0 to x of 2 plus sine t dt, we have to take the antiderivative of both of these. So this would be 2t, and then that would be minus cosine t if we do the antiderivative of sine t. And we need to evaluate that from 0 to x. But remember, this is still my g of x right now. So then using the fundamental theorem of calculus part 2, we evaluated at the upper limit, and then minus the evaluation at the lower limit. And then we work these out. So this is just going to be, and again, this is still g of x. This is not g prime yet. This is 2x minus cosine x. That's going to be 0. This is a 1, so that's -1, and another negative, so that's going to be +1. And notice we can prove that this is the same as this by actually taking the derivative of this function, because this is the general antiderivative, or the definite antiderivative, I should say. So this is going to be 2 minus a negative sine x, because the derivative of cosine is negative sine, and then derivative of 1 is 0, so this is 2 plus sine x. So notice we get the same thing for g prime of x no matter which way we use the fundamental theorem of calculus. So that's that for that.